Let's take a look at section 8.5, exercise 17, which is an amortization problem. So it's a paying off a mortgage problem. Assume that you have taken out a 30-year mortgage for $100,000 at an annual rate of 6%. Step A reads, use the table 8.6 above to find the monthly payment for this mortgage. So if we look at this table above, right, we want to look for where we have a 30-year mortgage. So number of years of the loan at the top is listed at 30 years and an annual interest rate of 6%. So if we look at the 6% and the 30 years, then where this row and this column intersect, we get this 6.00. So the payment would be $6 per $1,000. That's what this chart is telling us. $6 per $1,000. So the payment would be 100 because we have $100,000, right? So we have 100 of these groups, each at $6 per group of 1,000. So we are looking at a mortgage payment of $600 per month. So using the provided table, try to squish a T in there, it didn't really work. Using the provided table, we found that we'll have monthly payments of $600. Part B reads, construct the first 3 lines of an amortization schedule for this mortgage. Okay, so we have a payment of $600, and now they want us to make a table, right? So one thing our table is going to use, it will need is the payment amount, which for us is always the 600. We'll also need the interest paid and the balance. I'll give myself a little more space here. I'll put the table below. Okay, so just as a reminder, $600 per month. And we're going to need a table, right? So we want payment column. We also want to keep track of the interest that we've paid out of this payment and how much we've paid on the principal. Also from this payment. And now what's the current balance? They want us to provide 3 lines, but we start with a line of info. So you'll need to provide yourself with actually 4 physical lines to get 3 lines in our table, because we start with a balance of $100,000. All right. This location is P. Interest is P here. P times RT. which is for us P times 0.06, 0.06, because it's 6%, divided by 12. That's going to be our running formula. And then the amount that's been paid on the principal will be the payment minus the interest paid. So payment minus interest. So just to give us some formulas here. One thing we know is we're always paying $600. That's not going to change. So there's our 3 lines. That's 3 monthly payments of $600 toward our mortgage, right? So in the first payment, if we take our P, which right now is the $100,000, and multiply by the quantity 0.06 divided by 12, which is actually 0.05. 1, 2, 3, 4, 5. Then we see that we've made a $500 from our 600 is going toward interest, right? And the other $100 is going toward the payment on the principal, which brings our overall balance down to 99.9, because all we really paid was $100 on the balance. But now when we make the second month's payment, our P is now 99900 times 0.06 divided by 12, which is 0.05. And now on the second monthly payment, we've actually paid only $499.50 toward the interest, which means we were able to pay $100.50 toward the principal. So now we subtract that amount from the balance to find that now we owe $99,799.50. So that the principal 99799.50 is our new P, right? That's our new balance. We'll multiply that by the R over M, or RT, where T itself is 1 over 12. And now we get that we are paying $498.50. Oh, wait. Nope. Sorry. $499 is going toward our interest, and the other $101 is going toward principal. So our payment stayed the same at $600. We paid $600 in month 1. We paid $600 in month 2. We paid $600 in month 3. The amount we are paying toward interest every month is going down. The amount we're paying toward principal every month is going up. So the farther you get into paying off your mortgage, the more it's actually being applied, your payment is actually being applied to the principal itself instead of just paying off interest. So now, after our third mortgage payment, we owe $99,698.50 left on the mortgage. Part C says, assume that you have decided to pay off an extra $100 a month to pay off the mortgage more quickly. Find the first 3 lines of your payment schedule under this assumption. So let's take a look at what changes then. Right? Let's hit clear actually. All right, now our monthly payments are going to be $700 a month, right? $700 a month. So we'll have payments, interest paid, paid on principal, and our balance column. So 4 columns. And to make our first 3 lines of our schedule, we're going to actually need 4 lines. That way we can put our current balance on the first line, which is, if we're starting over, $100,000. Right, so we have $100,000. And our payment now is $700 a month. Oh, not 1,000. $700 a month. But the interest paid is still the same, right? Because it's based on P, which is $100,000 times the rate times the time, right? So $100,000, just like the last one, times 0.06 times 1/12 gets us $500. That means $200 is going toward the principal this time instead of $100, which now brings our balance down to $99,800, which took us 2 payments before. 2 payments before. If we multiply $99,800 times 0.06, the rate, times T, which is 1/12, because we're dealing with a month. We get that interest being paid is $499. The other $201 is going toward your principal. And on the second payment, with just paying an extra $100 a month, we're down to $99,599, which is less than when we paid 3 payments before. If we take $99,599 multiplied by R, 0.06, multiplied by T, 1/12, then we see that the interest that is coming out of our payment is $498, and the amount that gets applied toward our principal then is the other $202, which brings our principal down to $99,397. So when we're paying an extra $100 a month, an extra $1, it seems, is going toward paying off our actual principal. So here you have the table that we just created, only in print form.